Okay, so page 2 has you plot the points from that chart. So you plot -3, 1, 2, 1/2, -1, 0, etc. Okay, so when you plot those and connect them, you get this curve. So this is g of x, okay? So one thing to keep in mind, so it said g of x equals -1 to x f of t dt. So if you took the derivative of it, this becomes g prime of x. The derivative of an integral, remember this is second fundamental theorem, so that x just replaces the t, and remember if it's a constant down here, it basically just goes away. So the derivative is actually the original graph they gave us. So this is the derivative, this is the original function, okay? So if we're looking, they want us to talk about like decrease, increase, etc. Okay, and then we're talking about the original function. So the original function is decreasing from -3 to -1, and then it's decreasing again from 3 to 7. Okay, it's increasing from -1 over to 3. All right, it's concave down from -3 to 2, so just that little piece right here. All right, and then it's also concave down from 2 to 4. Okay, it's concave up from -2 to -1, and from 5 to 7. All right, and then one thing we don't really talk about much, I know we didn't in class, okay? There's parts of it where it's actually linear, so it's not really concave up or concave down. So from like 1 to 2, sorry, this is linear. Notice how it matches up with the derivative being a constant number. All right, and then it's also linear here from 4 to 5. Okay, it has a point of inflection at -2, 1/2. Okay, and that's because it's going from concave down to concave up. And then it has a relative minimum at -1, 0, and has a relative max at 3, 5. Okay, so there's page 2.